Nintendo Switch definitely has some structural damage inside the port. At least 2 of those pins are touching. We must remove the port before we can do any further testing. This video is brought to you by PCB. More about their awesome services in a bit. Set up to remove the port. Normally really like to gamify this and have you guys guess if there's going to be a secondary issue. However, there is an obvious problem. Yeah, that's not good, kids. That blew a hole right out of the Pi 3 USB, so our first order of business is not only going to be to remove the port, probably going to go ahead and remove the Pi 3 USB, and then we'll have to check around and see if we need to remove anything in the circuit with the Pi 3 USB. We could gamify it a little bit, and you can leave your comment below and tell me if you believe the CPU is dead. In the meantime, we will set up our equipment. And while we do that, I will throw up my temperatures. As always, these temperatures are brought to you by the Amazon associate links in the description. If you click any of those links and buy any of that equipment, or if you buy anything during that 24-hour session, a small portion of that purchase will go to supporting this YouTube channel, and it'd be greatly appreciated. It won't cost you an extra dime. Let's go about removing this port. We will keep the port handy because we may just be throwing it right back on. Someone definitely applied power to this one after damaging the port. Not good. Okay, port is gone. And we're going to go after the Pi 3 USB. This could very possibly be bonded to the board on that one burnt pad. Do we have a dead CPU? Yes, no, maybe. And what do you know? We don't have a short on the Pi 3 USB line. We are clear to test around M92T36. Let's check around the Pi 3 USB area though, because we did have a significant surge go through here. How did that filter not blow? Let's continue our testing. We will test, of course, the cap going to Pi 3 USB, which is no longer there. And we do not have a short. And then we're going to follow the lines going to the chip from the capacitors. These are the lines we do not want shorted to ground. So far, so good. Now this one has 2 lines going to the chip, and in that case, one line will always be ground. Alright, here's a big test. This is our CPU capacitor. If it is shorted to ground, we are donezo, but we are not shorted to ground, so excellent. This could be an interesting repair then. Okay, let's check around our MOSFETs. Very good. Check our little filter. It is fine. Let's check our invincible fuse and see if it's still being invincible. It is still being invincible. So nice of you not to do your job. Now let's check our test pads and see if we have anything shorted to ground. None of these should have a pathway to ground. And none of them do. Excellent. And we'll drop over here and check these test pads. Now them should have a pathway to ground, and that seems fine. This coil should not have a pathway to ground, but it should have continuity from one side to the other. And it does. Sometimes you have to work your way through the manufacturer residue. Don't get trolled by it. Sometimes it can lead you astray. Same rules apply for the BQ24183, except that it has multiple caps with multiple lines going to the chip. In that case, one side will always be ground. And we appear to be fine there. What we are going to need to do in our Pi 3 USB area is fix that burnt up pad. We need to pull out our fabulous pin grinder, and we're going to make ourselves a little bit of a runway here, so that we can run our, probably a lug actually. That should be plenty long enough. There's multiple ways to approach lugs, but I think in this case, with the fact that we need to route the tail, it's going to be easier if we secure the lug first and then solder it. Now, in order for this to work, we must have minimal flux residue here. That should be more than enough. Okay. Get it centered. We can scrape off anything that gets on top of pads. We're not worried about that. That looks pretty good. And secure it in place. Now we're going to route that tail, bend it like so. Very gently break off the rest real fast. Let's just test to make sure we got continuity where we need it. Excellent. Okay, let's apply some solder mask on this line. And curing round 2. Grab our delightful pin grinder and we're going to scratch off our pad. The lightest of touch. That should be more than adequate. Tin our pad. There we go. Okay, let's test from our pad to the filter. And we have continuity. Excellent. Let's wet our solder. What we're looking for here is the center pad to wet. That's what we need to grab onto the chip. Okay. I do believe our center pad has wetted. Sure it has grabbed on before you let go. Let it dry, just enough to tack it down, and we'll press down. Wet everything again, and let it dry again. Do any cleanup we need to do. Get the big blob first. And we'll touch it around there too. Make sure nothing's bridged. Pretty good on that side. Perfectly aligned, but they're all making contact. Same here, not perfectly aligned, but they're making contact. On this side, our lug pad looks particularly good. And for grins, we will test one more time. And no short. Excellent. So were you right or wrong about it being dead CPU? I know I was wrong. Let's talk PCB services. They offer custom CNC and 3D printing, PCB assembly, turnkey manufacturing, and they even have their own store. PCBWay always has some great promotions going. Hop over to PCBWay.com and check them out today. As always with the wick, you are just gliding. You are not putting pressure on, you are not scrubbing. I know it looks like a scrubber, but it is not a scrubber. You do not need any more pressure than what it takes to keep the wick on the board. Put any more pressure than that, you will do significant board damage. Put a ball of Kester 44 solder on our micro pencil tip, and then we're just going to glide over these pads with the ball. May make incidental contact with the iron. Generally, you're just trying to go over it with the ball of solder, like so. And again, we'll add a ball of solder onto our tip. Just kind of want to glide over with the ball as much as possible. There we go. Nice puffy pillows. And we placed our port. My method differs from others in the fact that I will heat it from the top. And the way I do this without melting plastic is I rapidly move the air nozzle. And what will happen is the board will accumulate enough heat to wet the solder pads, both the hidden row and the visible row. Do what works for you. Okay, we have wetted the visible pads and it is falling. But I want to make sure we get those hidden pads, so I'm going to let it go a little longer. As you can see, we're not melting plastic. Now I'm going to press down and remove the hot air. Continue holding down the port, and I'm looking for visual evidence that the visible pads have dried, and then I'm going to hold it down a tad longer just to make sure that the hidden row has dried as well. Now we're going to perform our gentle nudge test. You don't want to be ham-fisted about this, you just want to tap it. If you've only soldered one row, you will get some play in the port, but if you solder both, it should be pretty solid feeling, and it feels absolutely solid to me. Excellent. Good feed through to the other side. Outside anchors, it doesn't usually take a lot. While we're here looking, let's check our outside pins. Sometimes when you're concentrated on getting that inner row soldered down, these outside ones can get a little neglected, so it's always good to double check them. And they look good. And we have good feed through on all the anchor points. What's left to do is clean up all the flux, and then we'll set up for a power test and a dock test. The dock test will be a really big one for us. We're ready to do our power tests. We'll start with PSU dongle, and we're watching PSU channel 1. We're looking at the amp meter. We want to see it go up and then pretty much right back down. Excellent. See if it'll do it on the other side. And good sign so far. Now we will use our modified iPhone squid. We've retrofitted Nintendo Switch battery connectors on and switch light and activate. And what we want to see here is a steady climb in amperage with no hanging. And it does look like it's booting to me. What we want to do is boot up the switch. Okay, 0.47. Then we want to see a reset and then let it go into fast charging. And we are fast charging on both sides. Okay, let's try our dock. Excellent. That is good news. So that means our trace repair was good, the chip is good, and the port is good. And as you can see, we are back up on its battery. We're about at 9% charge. We are charging Joy-Cons. Just want to check and make sure we're getting Bluetooth connection. And we are. Make sure we're picking up our network. And we are. Excellent. Fan is spinning. And if you enjoyed this video, do me a favor and check this one out here. and I'll see you there.